about the joint probability and the marginal probabilities itself. So what is the joint probability when you talk about that? Joint probability is nothing but two events of probability when you are talking about. So two or more events onto that case called as joint probability. Yes or no? What is marginal probability is that? Marginal probability also called as simple probability itself. It talks about for one case of that, the simple probability combination with any other probabilities or any other events. Like one event, the combination of all the other events, like B1, B2, all the events, but it should combine with A itself. It's a one event. B1, B2 cannot be the in the one combination itself. Okay, that's a main rule itself. And B1, B2 all so on called as mutually exclusive events itself. And now you're doing A plus B1 and A plus B2, all that are collectively exhaustive events itself. What is that they call as collectively exhaustive events itself? Okay, let's move on to that with some solution of the problems onto that case. So I told you that what is this joint probability itself? Suppose you want to find that how many days of Wednesdays are in the month of January itself for a year of 2015. How do you calculate probability of January and Wednesday in the year of 2015? It tells that number of days that are there in January and are Wednesday divided by the total number of days on that year. So what is that? 4 divided by 365 itself. What is that? 4 divided by 365 itself. In that case, so this is a joint probability itself telling out that how many are there for that calculations of 4, that to 365 itself. And now comes with the marginal probability. Marginal probability is that what is the common here? When you see that what is the common? The probability of Wednesday is a common for that. So marginal probability is nothing but your single probability itself or the simple probability. So for one event, what is that event? For probability of Wednesday, for Wednesday, what are all the combinations we are studying out? So for January and Wednesday is one combination, not January and Wednesday is another combination. These two are combined together to form a marginal probability itself. Is that clear, guys?
Yes, sir.
Right. So let's see that marginal probability and the joint probability in the contingency table itself. How do we represent that? So there are events. What are the events? We have events of A and B. Yes or no? A and B are the events. Suppose take that. What is A event represents? A event represents of Wednesday or not Wednesday. A1 is in an example tells that A1 is not Wednesday. A2 is not Wednesday. What is another event? January or not January. So when you do that, and that's probabilities. So A1 plus B1 is the combination itself. It's a combination of one cell. What is that? The combination of one cell. A1 plus B2 is in the combination of another cell. But when you want to find out the total probability of A1, what is that? Here is the total probability of A1. How do you represent P of A1? For the next case, for which event? A2 event. How do you do that? Probability of A2 and the B1 is another event. What is the next one? Probability of A2 and B2 is another event of the probability. What is the total? Total is when you are looking for A2 event, what is the probability of A2? If you want the probability of B2 event, you want to search here P of B2. You want to go for B1 event, here is that probability of B1. So now what is the simple probabilities here itself? all green color lines or the green color cells. Okay, all the green color cells which are individually represented as individual probabilities called as simple probabilities or the single probabilities represented over there are called as marginal probabilities itself. All the combination of cells. Therefore, one or two or more events are called as joint probabilities itself. This is the way we represent in the contingency table itself. Is that clear, guys? Right?
Yes, sir.
Now, the probabilities till now we see are in the measure of that. What is that measure? We are seeing that. And for mutual and collective existing events, what could be the probability values which we get the is that we are seeing out now. So probabilities summary so far onto that, like what we have seen all that in the summary so far. Let's see that. So probability is what is the range of the probability, guys?
0 and 1.
0 and 1. So 1 is what? 1 is what?
Success. 0 is a failure, sir.
So a simple thing is that just a minute. Just give me a moment, guys, because we got a message on that. Right. Okay. In this case, sorry for that. Guys, did you get any message that OST is facing a technical issue? That you're getting any message on the screen?
Yes, sir. Yes,
Yes.
sir. It's same.
Okay. Okay. Right. Right. Because madam has joined from tomorrow. I will be giving that host itself. Today, madam has given the host itself, and the madam left. I think so. That's the reason you're getting the message itself. Okay, no issues. I'm calling the madam, but not getting the call. Okay, okay, no problem, guys. We'll see that if anything goes end, I will rejoin itself. Wait for the moment, guys, because I have host credentials. If something goes end itself meeting, okay, immediately you join after 5 minutes itself with the same link. Okay,
Yes, sir.
right, right.
Sir.
Because madam has given the host and she left out. All right. Okay. When you see the probability scale itself, what is the probability scale, guys? 0 to 1. So if that probability is impossible event which could not be happen, then you tell that it is a 0 scale itself. If it is happen for that which you are guessed out, then the probability is 1 itself. So you are not able to get that, and you have a chances for getting out 0 or 1. And in that scale, you can be in the probability of 50% chances itself. Right. Let's read out the points which are listed out there. Probability is the numerical measure of the likelihood that the event will occur. The probabilities of the events are between 0 to 1 onto that case for any event of that case. And some of the probabilities of mutual exclusive and collective exclusive. What is mutual exclusive? So if A is happening, B and C will not be happening in that case. Is it clear? If A is happening, what is that? B will not be happen. And if B is happening, C will not be happen in that case. But any of the two events are can be happen onto that case itself. And together all the probabilities, when you see that if A is happening, B and C will not be happening, then the probability is 1. If B is happening, A and C will not be happening, then the probability is 1 itself. But A and B are what is that? Mutually exclusive and the collective exhaustive events itself. Okay, let's see that some rules onto that. We have certain rules to follow. Okay, we have additional rule and multiplication rule, all that. Just a minute, I'll show you in the another slides itself. Right, guys? Can you see the another screen?
Yes, sir.
Right, right. We call them as rules of probability itself. What do you call rules of probability? Then let's follow what are the rules listed out in the probability. We have two rules for the probabilities onto that case. You know, I think that one is addition rule and then subtraction rule of that. Sorry, addition rule and the multiplication rule itself. The addition rule called as mutual exclusive events onto that case, where if you want to do that addition case like P of A union B, A union B is nothing but what is that A union B? It's a combination of A plus B itself. Yes or no? Or you can also written as P of A or B equal to P of A plus P of B. If A intersection B equal to 5, in that case, because A and B are mutual exclusive, what is 5? Guys, what is 5? Sumit, are you there? Sumit?
Sir.
Yeah, what is 5 here? Can
Sir,
anyone?
voice is not clear.
Yeah, my voice is not clear. Others, is my voice perfect or any disturbance coming out?
No, sir, your voice is clear.
Right. Okay. Can anyone tell that what is 5 here? 5 is nothing but null itself. I told you that A and B are, if you are talking about A union B, it's a combination of A plus B. But now we are talking about mutual exclusive, means one event is happening, another event will not be happen at the same time itself. Then A is happening, then B is not happening in that case. Then B is 0 itself. In that case, when you talk about A intersection B, means the combination of A intersection B, what are the other events again? There are no events onto that case, then you represent that is as phi itself, which is in the case of A and B are mutually exclusive events. Is it clear?
Yes, sir.
Right. So if two events A and B are mutually exclusive, then they have no outcomes in common. Yes or no? Because A happens, B will not be happen. They cannot occur at the same time. The outcome of the random experiment cannot belong to both A and B because they are mutually exclusive. That's what we are talking about mainly. So the addition rule in general, when you talk about A union B equal to P of A plus P of B minus of A intersection B itself. This is what general rule. But in the previous case, I talked about addition rule for mutual exclusive events. Clear? But in the general case, when you talk about A union B, P of A union B equal to P of A plus P of B minus of P of A intersection B, or P of A or B equal to P of A plus P of B minus of P of A and B itself. Is it clear? Is it clear, guys? Sorry. Right, Dinesh, Chandni, Avanti, is it fine? The
Yes,
addition
sir.
rule, right? So this is a general additional rule on that case when you study that 10th SSC itself. So let's see that logic onto that case onto that. So what is A union B, right? Is that when P of A is added to P of B, then the outcome is in A intersection B, because you have a common elements of A and B. That common elements are in that A intersection B are counted twice itself. Hence, A union B is equal to P of A plus P of B is a both combination minus of the element which is there in that. That's the reason we are counted twice. That's we are telling out. Is it clear? Sorry. Next, let's see an example onto that case. Okay, let's see an example. Saskatoon and Monotone are the cities competing the World University Games itself. Okay, there are also many others. The organizers are narrowing the competition to the final 5 cities also. Okay, there is a 20% chance that Saskatoon will be the amongst the final 5. There are 35% chance that Monotone will be among us the final 5, and there are 8% chances that both will be among the final 5. Is that okay? What is the probability that Sandstone and Monotone will be among us the final 5s? Is it question understand that all of you? Yes, Avanti, is it clear with the question? Guys, respond
Yes,
that.
sir.
Yes, Chandni, are you fine with that question which you're talking about?
Yes, sir.
Yeah, can you explain that once?
Yes, sir. The Saskatoon and Marquand of two cities, whereas there are competition or some games, World
Yeah,
University Games. So there
yeah.
are competition to the final 5 cities. Means last one is the final 5 cities are come to the winner point, and there is a 20% chance that Saskatoon will be amongst the final 5, and there is the 35% chances to Moncton will be amongst the final 5, and 8% chance that both Saskatoon and Moncton will be final 5. So we will be find the what is the probability that Saskatoon or Moncton will be amongst the final 5. Saskatoon or Moncton, both our cities will be finalist of that competition, and maybe one cities can be finalist amongst 5.
Super. Right. Okay. We have given a clear cut explanation. Your friend has given that. It's clear cut. Wait. Avanti, are you there? Because Avanti is showing that it's reconnecting itself. Okay, no issues. Let's get that. So we need to find out what is the probability that both will be among the 5 final list itself. Let's solve the question in a simple way. That. So let's take A is the event for Saskatoon, which is among us 5. B is that monotone is that. Then the probability of A is 0.20, probability of B is 0.35. What is the combination of the probability? What is the combination? A intersection is that both. A intersection B is nothing but your both. Is 8%, which is 0.08. Now you need to find out that A union B. A union B means A or B. Means what is the probability that Saskatoon or monotone will be the longest? Both, any one of that. A union B equal to P of A plus P of B minus of P of A intersection B. Simple is that 0.20 plus 0.35 minus of 0.08, which is 47% is the chances for any of one could be the final list itself. All of you clear with that question? Solution? Or any doubts? Clear, guys?
Yes, sir. Clear, sir.
Yes, sir, clear.
Right.
Yes.
Right. So if you want to get the complement, what do you do? 1 minus of that area. If I want A event of A complement, A event of complement, what do you do? 1 minus of P of A. Also can be written as complement means not A, which is not. Also represent 1 minus of P of A. Clear? So this is the complement of the total region. A is nothing but the event. In that case, I think you know all these events in that case.